Started here. So welcome to our little Family Day chemistry magic show that we're going to be doing here. My name is Mr. Boudreaux. I'm one of the instructors in the Department of Chemistry and Biochemistry. And we're going to be doing some chemistry demonstrations, science demonstrations with the help of our ACS student members over here. And before we get started on any of this, anytime we do any kind of stunts like this or something like this, I need to emphasize, don't try this stuff at home, okay? These are things that we have worked out how to do safely most of the time, so that we can do them without injuring ourselves most of the time. And the last thing that we would want is for you to go home and try to replicate one of these things and injure yourself in the process of doing this. Having said that, I'm going to put my safety goggles on because I'm rather attached to my eyes. Okay, so the first little demonstration we're going to do here is one that's called elephant toothpaste. Okay, now this is one you may have seen variations on before, but I'm going to just put some ordinary bubble soap in these containers here. So, okay. Now, the reason we call it elephant toothpaste, okay, you know how much toothpaste you use in the morning. We're going to make the amount an elephant would need. Okay? So we start with our soap here, and this is 30% hydrogen peroxide. Now, if you put hydrogen peroxide on a cut, does anybody know what the concentration of that normally is? 3% actually. You get to higher percentages like 6 and 10%. That might be what you use to, say, bleach your hair or something like this. This is 30%. You do not put this on a cut. Okay, you will have much bigger problems than the original cut. Okay? Now, just to make it visually a little more interesting, we'll put some food coloring in here. So I'll put some yellow in one and blue in the other, so we kind of get some ASU colors here. All right? Now, notice nothing is happening. All right? In order to make something happen, I have to add my initiator chemical here, which is sodium iodide. And hopefully I'll add this, and now we'll get our elephant toothpaste. Okay, most of it. Okay, so what happened here, besides the fact that I almost made a mess, when I add the initiator chemical in here, what it does is it causes the hydrogen peroxide to break down. And one of the things that it decomposes into is oxygen, which of course is a gas. So what happens is the oxygen gas that comes from the hydrogen peroxide blows bubbles into the soap, and it foams up. It looks like toothpaste. It isn't really. All it is just soap suds. Okay. Now you may have noticed the reaction steaming a little bit. This is what we call an exothermic chemical reaction. It does produce heat energy. If I were to touch the soap suds, it's not like so hot it would burn my hand or something like that, but it would be very uncomfortable. Okay? So that's our elephant toothpaste here. So I'm going to set these cans just have a little bit of water on them. I'm going to set them up here to boil, and I'll talk about what's going on that in a minute. Okay. Now the next one we're going to do is a color change demonstration here. Okay. Now this one we call the blue bottle. You might think that's a terrible name because it isn't blue, but now it is. Okay. And if we let it sit for just a couple of minutes, okay, it's fading. It should turn back to colorless. Okay? I shake it again, and it turns blue, and it'll keep going from blue to colorless, back and forth like this. Okay, what's turning it blue is when I shake the solution like this, there's some oxygen in the gas that's up here. The oxygen dissolves in the water, and there is a dye in here called methylene blue. It oxidizes that dye and turns it into the blue color. There's also sugar and sodium hydroxide in the bottle, and that reduces the dye into the colorless form. Okay? So I shake it, and the oxygen oxidizes it to make it blue, and then the sugar and sodium hydroxide reset it back to the colorless form. Okay? And it'll keep going back and forth like that for several hours. Okay? Now, this one we call the traffic light. Okay? So, 3 colors, of course, in a traffic light. We've got one of them here. So, we've got yellow. This is, by the way, a similar reaction. It just uses a different dye. This one, the dye is indigo carmine instead of methylene blue. Okay? But I shake it a little bit, and we get red. And I shake it a lot, and it's green. Okay? And what it should do is it will go back to red and then back to yellow. And then I'll be able to shake it again, and it'll do the same thing. So I'll leave that. That one takes a little bit longer to reset. So we'll check in on that one later. As you can see here, this one is still going back and forth. Okay. All right, sounds like I've got a little bit of steam going here. Okay. Let me go ahead and do the lava lamp first. Okay. Get this up to a good boil. Okay, now this one, depending on how much of a mess you're willing to make, or rather other people are willing to let you make, is one you actually could do at home, because the ingredients for this are really just water and some kind of cooking oil and Alka-Seltzer. Okay? What I've got in these bottles right here, this is just water and cooking oil. I've got a little bit of dye in the water just to make it kind of visually different from the cooking oil. And oil and water, of course, don't mix with each other. Okay? So the oil just floats on top of the water. So what I'm going to do is add a piece of an Alka-Seltzer tablet to the solution here. And the Alka-Seltzer hits the water, and of course it makes bubbles of carbon dioxide. And you can see it's kicking some of the water up into the oil, so it's circulating around. So it makes a kind of a lava lamp type effect here. Okay, we can do the same thing in the other one. Okay, the only difference in this one is that this one is blue instead of green. Okay? And this will basically keep going as long as you keep feeding it Alka-Seltzer tablets. Of course, a real lava lamp might get cheaper in the long run than buying a whole box of Alka-Seltzer tablets just to make a lava lamp. Okay. Like I said, this is one theoretically you could do at home, but also theoretically, possibly not theoretically, you could make a horrible mess with this. If you add, say, too much Alka-Seltzer at once and it foams, you end up with oil all over the floor, or even worse, oil all over the carpet, which would definitely not be a good thing. But like I said, that'll keep going as long as you keep feeding it Alka-Seltzer tablets. Oh, and my traffic light reset here. I'm back to yellow, and then red, and then green. And like I said, it'll keep cycling through those colors every few minutes or so. Okay. Now the next one I'm going to do here, I've got a little bit of water in all of these cans, and the water is up to a boil. Okay. Now, so it's turning into steam, which is, of course, gas, and it's right now it is under atmospheric pressure, 1 atmosphere basically of pressure. Okay. what I'm going to do is I'm going to take these cans off and I'm going to turn them over in this container full of water. And what that's going to do is it's going to seal one end of the can because the open end is going to be underwater. And it's going to take all of that steam in the can and it's going to cool it down almost immediately. So the pressure inside the can is going to almost disappear. But there's still going to be 1 atmosphere of pressure outside the can. And we're going to see what that pressure difference does to these cans. Okay? So I'm just going to take one of these and turn it over in the water. Okay? So that's what the air in this room can do. Okay? If there is atmospheric pressure outside the can, but almost no pressure inside the can. So let's see what these will do. Okay. Now you notice there's a lot of water coming out of the can. I didn't have anywhere near that much water in there to begin with. That's because there's a little bit of a vacuum left in the can, and so that's just sucking some water from the container up into the remains of the can. Okay, if you look at this one from the side, it's almost flat. Okay, so we've got this pressure basically pressing down on all of us. So we're all under atmospheric pressure like this. We might be under other kinds of pressure as well. But we're all under this atmospheric pressure like this. But if you take away the pressure that's inside the can, that shows you what that atmospheric pressure is capable of doing. Okay? About like that.
This first one is going to be strontium, which produces a red flame. The second one is going to be potassium, which produces a purple-ish flame. This one, I believe, is...
I think that's the sodium.
Yeah, so it produces a yellowish green flame. But the true green flame is going to be this one, which is boric acid, or boron. Then we have copper, which produces that nice purple-blue color. And then finally, lithium. Yeah, this is my favorite.
Yes.
And now we just wait for it to go out on the road because I'm not plastic unless we're going to put the tops.
Yeah, we can put the tops on. Okay, we can let it burn for a minute.
So pretty.
I love the color of the lithium one.
Look at that one. It's dark.
All right, if we can go ahead and smother these. Well, I hope you all enjoyed our presentation here, and thank you all for coming, and I hope you enjoy the rest of Family Day.
Just the way day, left me dreaming here for days. Every time in a different way, in a different place.